due to technical difficulties, DIY with Papa Izzo has been preempted for... Next week, we will be returning to our favorite Papa Izzo and his DIY experiments. But for this week, I am still your moderator, Izzo. But please join me in welcoming my senior switch, Austin, our one and only student, Teddy, and our guest speaker, Nathan.
Record.
Okay.
We are recording now. Keep it PG-13.
I would hope it's PG-13.
Try at least.
How
All
many
right, wait.
F-bombs do we get?
What?
No, Nathan
Zero.
never swears.
Dang.
Nathan never
Zero.
swears.
This
He
is
is a
DMU.
Christian boy.
0 F-bombs. All right,
Okay.
Austin, I want you to introduce Nathan first, and then Nathan, I want you to take it away. Okay, buddy?
Okay,
All
sounds
right.
good.
This is Nathan. He is a graduate from CCS in Michigan, which is College for Creative Studies. And he has his bachelor's in, what was it specifically?
Fine arts.
So he's very good at doing art for video games. So like anything 3D that you would see in a video game, like, or even like movies, like anything animated like that is something that people like him do, and it's very involved with geometry.
Mm-hmm.
Awesome.
So instead of saying this will never benefit me in my life, you can say this will never benefit me in my life if I don't intend to go into this very specific profession. But it's been very helpful for him, I guess,
Yeah.
considering all the stuff he has to do. So
Awesome. Nathan, take it away for us.
All right.
So, how do you make the characters?
So characters are similar. So the one that you see that I was just walking around with, I didn't make that. So that's default. That's Unreal. They give that model to you to
Awesome.
essentially walk around in your scene like I was, to make sure everything looks right from that perspective, essentially.
And it's a good thing they do, because I mean, just to show, you might want to just go into the blueprint of the character
Oh yeah,
to show how much actually goes into making it move and interact with everything.
right.
Edit
Which-
blueprint
Been a while. Where is the
and the
oh, right here.
details.
I can send you the here.
Nope.
Do you have Discord on your here? I can send you the progress thing
There.
for Terra Leaf. This
That's
is one of our creature designs. It's not humanoid. It's one of the essentially Pokemon.
that is the basic coding for a character
Yeah. So
in Blueprint, which makes it a little easier to.
Okay.
It's like
right.
if you were to open up an actual like code window, it would look a lot more, I guess you could say, messier.
Yeah.
A lot more intense.
Yeah, it would look a lot more confusing than what this looks like. So essentially each one of these little things is a node. And
Okay.
this node has a code plugged into it so that when you plug it into something else, like this control, that it basically executes that, and it puts together those two code pieces for you, so you don't have to sit there and type it out and type it out and type it out and type it out.
Yeah, very helpful.
And that one's for a controller specifically.
Yeah.
Or looking around and moving.
Right.
Okay.
And then, yeah, I mean, all of these are labeled too. So this right here, I didn't make this. This is what Unreal gave to me to be able to, see what my world looks like at that perspective, essentially.
So not only does it need a lot of geometry, but it also needs a lot of coding.
Yes.
Yeah.
That's a lot.
Which actually is interesting because all of those pieces that I made
Mhm.
are also just a bunch of coding. So what Unreal's doing for me right here, Maya and Blender are doing for me while I'm modeling.
Okay.
So it's like so I can take vertices from a square. I can select all four of them on the top, and then I can just shoot them straight up to make it a tall box. Or I can shrink it, or I can do whatever I want with it. But that's basically the program doing code for me. So when I click that button to scale up those pieces, it's all saying, okay, this is the code to scale, this is the code to select these vertices, this is the code to do this, and it's all just mashing it together to make it really easy for me to use as a modeler. Yeah. So
It's very important.
mhm. Yeah, so we have we're working with a couple of other people. So I'm the environment artist, so I handle all of, environment stuff, trees, buildings, XYZ, you name it. We have other people who do the concept art for all that stuff. So we have an environment concept artist, and then we have 2 character artists, concept artists, and then we have a modeler as well. So it starts out with this, which is the concept art for the character, and in this case is the finalized concept art. And then they have a turnaround of the character so that modelers like me can make sense of what it looks like in space, essentially. So like, okay, well, those arm folds, I can't really see it from this side profile here, so I got to turn it around and be able to see, like, okay, so that's how it's supposed to look. That kind of stuff.
Okay.
So then we go into Blender, and then we have a modeler go through and essentially create this concept into a 3D model. And then after that, it turns into something textured like that.
Oh, cool.
Mm-hmm.
Well, they have to draw the textures.
Yes, hand-drawn.
Fancy.
Mm-hmm.
So is it like a wire model type of thing?
Yeah, so you can't really see it here, but he's got smoothing on it. It's just a bunch of quads and triangles.
Okay.
That put this together.
I can send you the human one that has the...
Oh yeah, sure. Basically what happens is these 3D programs usually calculate things in quads and triangles.
Oh, okay.
Typically more so triangles than anything else, but it's more difficult to analyze a triangle to the human eye than it is a square.
Really?
Yeah, so it just makes more sense to you while you're looking at it to do it in quads as opposed to triangles, which is really interesting. But essentially, we take this model here, and it was sculpted first. So they had, like, you can see all these squares and stuff here.
Yeah.
Imagine that like quadrupled. So you have even itty bittier squares in between all of these ones, so that you have more information to be able to sculpt all the features. So you get the muscle definition, you get, the eye sockets, you get the ears and all that kind of stuff. And then to make it game ready, because game engines, especially when they have a bunch of stuff all together in one file, it starts to bog down that process if it's too heavy in geometry. So we try to bring down the amount of quads to a specific level. So basically we can have a bunch of these walking around all at once instead of just
Right.
one.
So you have to start with the more complex and then work your way back
Yep.
down to something that will more easily render.
Exactly. Yep.
That makes sense.
We usually so I was taught that whatever your heroic asset is, so whatever's going to bring the most attention, whether it's a rock, whether it's a character, whether it, XYZ, you usually want to spend about 100,000 to 500,000 polys.
Okay.
If you go over or if you go under, it'll mess it up slightly, because if you go under, it's not going to look as high quality, and therefore your heroic asset it looks like a turd,
Right.
essentially. But if you go too high, yes, you'll have a bunch of high definition and stuff, but then your computer can't run it because it's too much calculation.
Which is not helpful.
Exactly. So the computer is always, especially in 3D programs, if you're going to use a 3D program, you need to have an exceptionally good PC to run it. But basically what's happening is when you're creating a 3D object, the computer is always processing like what that looks like, and it has to take into consideration when you're moving that entire object 90 degrees, it's not just taking a single object, it's picking all of those vertices that are making up that object and recalculating each one of those in the program to be able to move it.
Right, because some of them would then warp and shape a little bit, like depending on what your character is doing.
Yep.
So if they're running, certain quadrilaterals would be extended or contracted, right?
Yep, exactly. And then that's a lot of the time you get like pinching and stuff. So if you have a lot of the time pinching happens like by the mouth, because like when you're making up a character, you want to follow your geometry around, places that would be, stretching out the most. So like when you're talking, all the skin around your mouth is constantly moving. When you move your arm, the skin on your elbow, if you bend it all the way back, it's stretching to basically encompass that whole bone structure. So if you don't have enough geometry, you get something called tearing. And that makes it so if it's stretched out too far, that texture that you put on it later is going to look really warped and messed up when it's laying on those quads.
Oh, interesting.
Mm-hmm.
So that makes sense then with the face, since that's what moves the most, that you would need a lot of quadrilaterals there.
Yep, exactly.
Okay. So what program would you do something like this in? Would it just be the Blender?
Yep. Blender, Maya, ZBrush is a sculpting program. It's basically, what's really cool about Blender is it's got all of the tools in one program, basically. So it's talking about that efficiency that was going back to with like speed tree and stuff. Yeah, I could do a tree in Blender, but it's going to take me a hell of a lot longer than it would if I were doing it with speed tree.
That makes sense.
And so if I can eliminate having to jump back and forth between two programs like ZBrush and Maya, because those two programs have completely different tool sets. In ZBrush, I'm sculpting, so I'm using a tablet and pen in front of me to actually, it's almost like I'm sculpting a block of marble, if you will.
Oh, okay.
And then what would happen from there is I would export that from ZBrush and I would put it into Maya, and then I would do something called a retopology, which is taking all of that dense geometry that I have from ZBrush, because the more geometry I have to work with, the better definition and quality I can get and detail. And then you bring it in for retopology so that you can simplify the geometry, which is what you see right here, but then you can also bake that light map texture that you get with the high definition to the low poly. So it's basically like I still have the high definition because I've sculpted it already, and I'm taking that light information and slapping it back onto the lower poly version.
Got it. Okay.
And so it still has that good definition and all that stuff.
Like a texture almost.
Yes, it's exactly like a texture. But they're just real simple stuff.
You're on rock 2. Everything else is.
That's right. Everything else is hidden.
There, yeah.
There you go.
There's some more rocks.
So what would you do with these rocks? Just place them randomly in the game?
Yep, they're also made modularly. So it's kind of interesting because like Austin's like, it's a rock, it should be really easy to make. You should be making these so fast. And it's like, okay, but you have to understand, because like if I want to streamline this as much as possible, I want one side to look completely different than the other. So it's up to me as a designer to, take that into consideration. So when you place this rock and duplicate it several times, but you turn it slightly and like sink it down into the ground just a little bit, you wouldn't be able to tell that that's the same rock.
It's a completely different rock. So you can do multiple rocks just on different rotations, reflections, and translations.
Yeah.
Suddenly they become completely different rocks.
Exactly.
And it's really interesting because Unreal Engine will actually do those for you randomly. Like you can select what you you can select basically a range of how much you want to turn them.
Oh,
It will
okay.
do it for you.
Yep.
So you just
Of course,
plug
sometimes.
in, like a center radius and direction, or center angle and direction to tell them how much you want one of these rocks to rotate.
Yeah.
Yeah.
Yep.
Okay. Very cool.
Yeah. I sent you on Discord, Nathan, a screenshot from Red Dead Redemption 2.
Oh
yes.
Just so
God.
you can show
The-
Izzo some actual insanity.
Yeah.
Squirrel. Squirrel says hello.
There's Squirrel.
Oh, kitty.
Hey, squirrel. Hi, squirrel.
Hello.
You woke up from your nap. We're worried about you. Ooh, those are pretty rocks.
Yeah. So there are some game companies that like to go crazy with their stuff. So they're the people who have the money to spend on inefficiency. And so each one of these rocks that you see are completely different.
Wow.
Every single rock has been placed individually. It's not modular. They don't need to spin them around and, do fancy stuff with them. But it turns out to be a gorgeous scene
Yeah.
regardless. It's at that point, it's more of like something that you get to flaunt. Like, yeah, every single thing that you see here is not one of the other pieces. No piece is the same. But it's more costly for sure, because now you have one artist doing just rocks for the entirety of the project, where it could be just, okay, you get to do 3 rocks, you're good. You get to do 3 rocks, you're good. You get to do 3 rocks, you're good.
That's not even an exaggeration either, because the one person that I talked to who worked on this game was literally just doing rocks for 4 years.
Rocks.
For 4 years.
4 years.
4 years just doing rocks.
Yep.
And they had
That
over
is-
2,000 people working on the game.
Wow. That's a lot of time spent just taking a look at rocks.
Yep.
Yeah.
Yeah.
I feel like it would be hard to come up with a new idea on what a rock should look like.
Yep.
They must be doing like a lot of hiking.
Yeah.
I mean, correct me if I'm wrong, Nathan, the rocks you see there are like incredibly heavy in polygons, right?
Actually, no.
Oh.
These are probably relative to the amount of geometry I showed you on my rocks. Oh my gosh.
It's
what's
just
going
they
on?
have a texture map and
Yeah, so they probably sculpted those rocks in ZBrush, and then they took that into Maya or Mudbox or whatever it is that they used, and they took that sculpted mesh, and then they turned it into a retopologized low poly version, and then they basically baked the light information from the high poly, the sculpted one, and took it and threw it onto the low poly. So even though it's low poly, that light map that they throw on there is going to basically dissolve this edge, so it looks like it's all smooth here. Where you can obviously see there's a very depict line of where all those polygons are. But once you do that light map, you can practically make it look like anything with a light map.
Transformations can frequently be put together in a multi-step process. This is called a composition. We translate the shape and then dilate it. In this graph, there are actually 3 steps to the composition. Mathematicians don't like to write, so they've actually developed a shorthand for all of this. Technically, you could write it out in one big long paragraph.